Hello, everybody. I'm Michael Monaco.
And I'm Bobby Salvesen. We are the Hazmat Guys, bringing you knowledge and insight to make your job a little bit easier and safer.
Let's take a minute to hear about today's sponsors.
Hey guys, time to level up. New and exciting detection technologies are available, and All Safe Industries can help you navigate the details to make the best choice for your hazmat team. All Safe Industries, where your job is a safer you. Call or click today. Hey guys, Bobby from the Hazmat Guys here, and have you noticed that threats have evolved but decon hasn't? Well, that's until now. Hybrid decon is the latest evolution of decon tools and techniques. The concept of hybrid decon has been getting a lot of attention in the hazmat community, but what exactly is hybrid decon? Well, First Line Technology, which are the developers of Dahlgren Decon and FiberTech wipes, have produced a downloadable 24-page brochure that explains the concept of hybrid decon and why it is a major improvement over either wet decon or dry decon alone. This brochure answers all the questions you might have about how to simplify your hazmat response. You'll learn why using Dahlgren Decon and FiberTech wipes together will reduce the time it takes to set up, mix, apply, and clean up after or during an incident. You can download this free copy of What is Hybrid Decon brochure at www.firstlinetech.com or simply click on the ad below on our website.
Let's get to the show.
Hey everybody, welcome back to another pleasant episode of the Hazmat Guys. I'm Bobby Salvesen. I'm here with Mike Monaco.
Hey, everybody.
Wow, that was loud.
Yeah, not pleasant at all.
Not pleasant, a little boisterous, a little too much. Just to, I think the only conference is Mike is going to rock it out at Cold Zone.
Cold Zone, baby.
June 24, 2020, and he's going to be knocking it dead out there.
Yeah, they should just for 2020, they should name it Warm Zone because it's a little, doesn't really fit if you're not there freezing your stuff off.
Yeah, it should be Tepid Zone.
Tepid Zone, yeah. Lukewarm.
Lukewarm.
Tolerable would even be nice.
We can go so many more adjectives on that, but that would not be a family show like we have. But you know what? Check out the university. We have a couple of new courses up there, a couple of case studies that are really good. Very popular.
Getting really good feedback on the case studies.
Yeah. They're... You know what the funny thing is with case studies, not to go too much down a rabbit hole in this one, but it's like you watch like a case study on like YouTube and you're like, all right, that's interesting. But when you have somebody like really tease it out and say, okay, we're talking about chemical and physical properties like vapor densities, and like you're like, holy crap, that just completely changed that video.
You know when you've got a good case study, like the one that Lieutenant John Cassidy does,
yes,
right, the chlorine one,
the Syria, yeah.
Where you turn around, and by the end of the case study, you're like, yeah, duh, that's so obvious. Like, why would you do that? But clearly, before you had done the case study, if you weren't in that situation, you would have done exactly what they did. But by the time you're done, like, it gets set up in such a way that you're like, yeah, of course, that makes so much. Like, why wouldn't I do that?
Yeah, exactly. So that's a good one, and I think it's relatively lightly priced. We'll say
it's a good price.
It's a good price. It's a tremendous price. What a bargain.
What a bargain.
So, what are we going over today?
We're going to talk a little bit about some advanced neutralization techniques, and we're going to kind of pop the bubble on one of like the hallmark don't ever do this in hazmat things.
Yes, and I'm glad we're finally doing it. And if you go back through the epochs and the aeons of our email of our podcast, the thousands of years we've been podcasting on this venue, since the dinosaurs were roaming the earth, we've been
dogs have been in
podcasting about dogs have been in firehouse for thousands of years. We've been talking about this subject. If you go way back, we've always pushed you guys away from doing this.
Yes.
But I think it's about time to finally tell you how to do it.
Well, we started this podcast. Obviously, we weren't quite sure how to approach a lot of topics, right? Because we all know there's like the stuff that you learn in class and is the official textbook definition. And if you've never done something outside of like that official textbook, like, no, this is how it's done, then you're really, I'll be honest with you, you're not doing your job, right? If you can't say, yeah, no, I've bent to those rules many a times. So that's what we're going to do. We're going to kind of dive into something. We're going to talk about it a little bit and describe why now we kind of feel comfortable being like, listen, we could go outside the box a little on this one.
Well, you know what? This kind of, when we got this possible incident from a listener, and we're going to play those parts as if it was us.
Oh, yes. No, clearly not us.
No, yeah. It was sent in from Phil, I think it's Phil McKracken,
Yep.
from way out in the corn bush. I don't remember where it was. Little Big Neck Cove Fire Department or something like that. I don't know.
Yes.
Got us this incident. It's a very interesting one. But after this was done, a couple of the newer guys came up to Phil, and they were like, listen, we just came out of your technician class, and you said specifically not to do this. And he was like, yeah, but now you're on the hazmat team.
Right.
Like, that's what we tell the regular guys. Now you're on the specialists.
Do as I say, not as I do.
And we're going to talk to you about what I don't want to say like what we would do or we're just going to put a couple more tools in your toolbox. How's that?
Some thought processes.
Some thought process. And you can myth bust this. We encourage that. Myth bust what we're saying.
Right, because we want thought process, right? All of our techniques should be based on thought process, not, well, this is what I learned. If your answer for how you do something is this is what I learned, you're doing yourself a great disservice.
Right. It's like saying, oh, I stayed in a Holiday Inn Express last week.
Right. When
like
clearly a Marriott could be a ton better.
Of course. Of course.
We're not.
All right.
We're not pushing anyone. Just so that was totally made up on the spot. There's no product placement going on here, unless they're going to cut us a check, and then we'll talk about Marriott every freaking episode.
The best.
All right, but today we're going to be dealing with a variation on neutralization, right? Acids, bases.
Right.
Most of the time, we think about an acid or a base, and we think about it as something that has spilt out, because that's what happens, right? We respond to an incident, a container, a breach. Like if you even look at the how a product gets out into the atmosphere, what's the insult to the container? Is it a thermal? Is it a mechanical? How is it released? Like, it's always spill. But sometimes we need to neutralize a really, really strong, really, really dangerous container that is actually still, a dangerous chemical that is actually still in its container with an extraordinary amount, an extraordinarily lacking amount of space. So how do we go about doing this?
So here's the problem. When you have a very strong, and again, you know what? Can I pause this for a second? I just want to
pause.
I want to break this back because I want you guys to understand. We've gone into this quickly, but I want to go over this because this is a confusion point for a lot of guys, even in the advanced companies, is that when we talk about corrosives, we usually talk about pH. Right, pH.
Right, so obviously a strong pH is like a 1 or a 0.
Right, 1. Okay, but again, Coca-Cola is a 2, and we drink it. So therefore, we bring in the dilution, which is also called concentration in the trade, right? So we have pH, which is the potential of hydron, right? And we have concentration, which is its ratio to water. And the third thing is the strength, not to be confused with concentration. The strength is how completely it dissociates. Right, so if I have something like acetic acid that likes to drag its feet about, dissociating, well, it doesn't uncouple, if I could use that word, as fast as hydrochloric acid. So it's a relative term like volatility. Right. But it's an important term because confusion between definitions, between actual words, means something on the street. Like, so if I say, Mike, this is a strong acid.
Hey, hydrofluoric acid, strong acid. Nope, it's not.
Nope,
it's actually a weak acid.
Right. So what I'm saying is how fast it dissociates by saying strength. Concentration is its ratio to water, and then you have potential of hydron. So getting back into this, when I say a really strong acid, we are probably talking more of the concentrated, maybe high pH, maybe strong. So all three of these terms, you could put them in or take them out as you wish. But what we're saying is it's badass.
Yeah.
Right? I don't care how you mix it up. So we have some stuff that is strong. We're going to use that. You know what? Let's just call it this. For the sake of this episode, when we say strong, we're talking about all of it.
All of it. Highly concentrated.
Right? We're not, just highly concentrated.
pH
highly
on the extreme.
pH, and ready to dissociate if you even talk bad about it.
Right. And ready
Right,
to
so
just yank an electron off anything.
Anything. So if we say the word strong, we're not saying about, but what I just said. I don't think I have to repeat it. So when we have a really strong acid, they don't typically react or mix well with not so strong stuff, right?
Right.
So when we make our quote-unquote slurries, right? Again, definition of slurry is a solid that's in suspension in liquid and doesn't truly dissolve. Many of these things will react with water, right? So if we were to take acid and put it into water, the correct way of doing this, then it works right. But if we take water or a slurry and put it into a strong acid or base, she gets a little angry about that.
Right. And the that general rule, right? If we were to take this actual what would be the best way to describe it? If I were to take this actual acid or base, this really strong, let's call it, let's say what it is. It was a nitric acid.
Okay.
It was a really, really highly concentrated nitric acid. If I were to just take that nitric acid and dump it into something, I'm kind of breaking that like cardinal rule, right? Where, you don't mix, you add the acid, you add the acid to the water, not the opposite way around. Okay. So the tip number 1 for all this in our 5 tips is a strong acid and bases, you would add the base and the acid to the water slowly. So we have that nitric acid, and we are going to add it to the water. We know that it is going to be something that is volatile, and not volatile in the, I just used the wrong word. Wow, I should be smacked right now.
Tisk.
Oh my God, I feel so demeaning.
Thank you for your last show, Mike. This is it. You're out.
You are the weakest link. Goodbye.
Oh, yeah,
but it is going to react violently. So if I try to put the water into the nitric acid, you don't want to do that, right? And we want to add whatever that acid or base that we're going to neutralize. We want to add it slowly.
Right, and here's why. Because think of water as a heat sink. It sucks up heat energy, right? So when we put an acid or base into water, it is going to go exothermic. We understand this. However, you probably won't see it happening very much. Or you might see a little bit, but you won't see it much because the water just eats that heat. And so as the acid starts to dissociate in the water, it absorbs a tremendous amount of that energy. It doesn't really leave all that much. And when you think about a small couple of drops going into a bucket of water, it takes an awful lot of heat to move that even 1 BTU, right? Or calorie is
Calorie, yeah.
Right? So allowing the acid to safely transition into solution.
So how then do we do this situation? The key is to safely make this happening. We first need to get a container to perform the titration in, right? We're not going to titrate it in the little container, and we need to figure out how to get the acid to the water, so we get a container. Since we're dealing with acids and bases, it's really important to make sure that whatever container that you're going to grab is going to be compatible with the product. So, if you have something that the acid is going to eat steel, don't use steel.
Yeah.
If it's going to eat plastic, then maybe you need to get glass. You just need to make sure that every step along the way, including your personal protection equipment, is all going to be compatible with the strong substance that you're dealing with.
Right. So in this instance, our good friend Phil, Mr. McKracken, had nitric acid, and they used a 5-gallon Home Depot spackle bucket, emptied spackle bucket, and they filled it half with cold water, so about 2.5 gallons ish, right? Which is a sizable amount, right? That is a good amount for the 16 ounces of product that they had.
Which leads
Now,
us.
Yes.
Go ahead.
Now, I was going to say, I don't think. In fact, I think it was handwritten on a label that said nitrico acido or something like that.
Yes.
And it had no concentration. It had nothing other than 2 Spanish words handwritten on the label.
Yes, it was, I believe, an artist shop. So, they're not quite up to date with all their.
Yeah, they didn't have the SDSs.
Yeah.
It was terrible.
We asked for the MSDS books and the right to
Nothing.
know, and they were like, "Okay."
Okay.
So, this leads us to tip number 2 in doing it this way. Now, it's really important because we're going to get to that aha moment in the end, why we're doing all these tips. Tip number 2, make the 2.5 gallon water whatever dilution ratio you feel comfortable with. How, right? 2.5 gallons may not seem like a lot of water, but no one says that you have to dump all 16 ounces in at once. This is the key to doing a really strong acid or base safely and working with a very limited volume.
Right. So let's dance this out to explain what we're talking about here. When you have 1 gallon, that's equal to 128 ounces, which I don't know why we have to still memorize these stupid numbers. Like, that is, can't it be like 100?
It should be. Well, if we weren't using this barbaric system of measurements, we would, but that's...
That's beyond me. Whatever. Anyway. So in 2.5 gallons, quick math is we have 320 ounces, right? So if we remove 1 ounce if we put 1 ounce of that strong nitric acid in this place and we place it in a bucket with 320 ounces, we have a 320 to 1 dilution, right? That is a significant dilution. That's a good size dilution. Will it bring it to neutral? No. No, it will not bring it to neutral. It might not even move it 1 click on the pH strip. But now when we neutralize, we're dealing with a much safer product because we've brought the concentration down. pH, probably negligible. If it moved, you wouldn't see it on your pH strip. Strength, unaffected. But concentration moved sizably.
Yeah, which makes a big difference in that long run because here's the magic to this, right? There is no magic to the number 320 to 1, right? We just made that up because we were using a 5-gallon container. So like many of the other things we do, observations become a key to neutralizing in this manner. If I took my ounce of product and placed it in water and there was a huge reaction just from that 1 ounce, I would consider dropping down to half an ounce or a quarter of an ounce or even titrating drop by drop if need to.
Right. Yes, that's a really good point because, or you would just make it into a bigger drum.
Right.
You can also do that. You can also flip the other side. So that's a big deal. And one of the problems with this, especially with fire and police, is we want to do it now. This is a slow.
It is a slow.
You got to pump the brakes on these things. And so with that, the opposite is true. If we're putting this acid or base into water and we're noticing that there's no reaction or nothing, there's really nothing going on. So you're like, I'm not really getting a lot of heat coming from the water, and every time I put a little bit more, it's relatively calm. What does that mean? It's not really doing anything. I'm just kind of putting it in there. So now you can say, well, instead of putting 1 ounce, maybe I'll put 2, 3, right? I'm not going to go and get a new bucket because that's a wasteful thing.
Right.
But I might say, you know what? I'll put half of it. So observation. Observation.
It's the key to the whole thing. It's funny. The incident commander came up to one of the guys on scene and says, when they're all setting up and the guys are getting geared up in their little outfits, he's like, how is this going to take long? And the guy was like, no, like 3 hours max. This will go pretty quick. This is an easy one.
Yeah.
And his face dropped, and he looked like he was... It looked like someone peed in his cornflakes. Anyway, what it comes down to is we want to create the safest situation possible, and then we can readjust anything we want from there. That way, things start off in a simple manner, and if they go wrong in the smallest possible manner versus trying a large concentrations and having things that had a catastrophic effect.
Hey guys, Bobby from the Hazmat Guys here, and emergency responders across the country rely on CAVCOM for mission-critical two-way radio communication. CAVCOM's Talk Through Your Ears technology is compatible with any suit, any respirator, and any two-way radio. As an in-suit communication experts, CAVCOM has developed a completely independent communication system that can be truly advancing to your team's ability to stay fully connected regardless of the task at hand. Whether you're working from a command position or responding downrange, their two-way communication solutions deliver the clarity, durability, and reliability that extreme situations demand. CAVCOM will be at the 2020 IAFC in booth 321, where you can experience a live demonstration, and you can see and hear the difference with Talk Through Your Ears. If you can't make it to IAFC, call today for an on-site demonstration of this revolutionary system at 866-547-4988, or visit the website for additional information at cavcominc.com. That's CAVCOMINC.com. All right, let's pick up where we left off, which brings us to tip 3, why we neutralize in steps. So when we have our 320 to 1 dilution solution, if you would, we're going to take steps to neutralize this, right? We're going to try to bring this to a balanced pH. That's the name of the game, of 7-ish. And for Phil's locale, he said that their DEC, or Department of Environmental Conservation or whatever, says you can pour it down a drain between 5 and 9 on the pH scale. Mm-hmm. So Phil bought strips that only say 5 to 9.
Yes,
he pours everything down the drain.
Everything comes up green.
It's incredible how this works.
We actually just cut up green construction paper and dip that in.
Just dip it and be like, wow, that's so weird.
Look at that.
So, we're going to put another ounce, right, in there, and we're going to keep going until we've neutralized all of our product. Did I mention that right? Did I say that right?
I believe so. I think I understood it right.
Okay.
Right, but what we're trying to do is essentially we're creating different safety steps that allow us the flexibility to operate in a manner that we're going to talk about a little bit later. The other thing that it does is it allows me to constantly always have that 320 to 1 dilution factor, or whatever number you have, and that dilution factor, it's always going to remain the same every time I go to neutralize.
Right. So the objective is, and if just to pull it back a little bit, when I put an acid plus a base, the typical reaction is acid plus base equals exothermic, energy out, a salt, precipitate, and a gas produced. In most of these cases, it's going to be some type of salt water, right?
Right.
And you're going to have a carbon dioxide release, and you get a little bit of warmth.
I don't know if I try putting fish in it, but yeah, it's definitely salt water.
Yeah. So every time I try to bring my solution back to neutral, I'm starting over again with a fresh bucket of water, right? So I put my little bit of neutralizing agent in there, and it evens out, and then I do it again.
And this is how we do it over and over again in the same small spot with the same concentration and the same dilution, because we're taking that high-strength corrosive, putting in a bucket, and you're maintaining 320 to 1 every time you neutralize.
Right. We've turned it into water. It just becomes part of the solution.
Yes.
So, let's hijack this. Let's take it to where we tell people generally not to go.
Okay.
Okay.
Well, what are we telling them?
Let's do the dry neutralization.
No. Heresy. Absolute heresy. Nope. You have violated some code. I'm sure somewhere there's something that is like a Bible thing. Like, I think the 11th commandment has just been broken.
Let me explain why we're even mentioning this. Because if you have a liquid, acid, strong, base, whatever it might be, and you add slurry, you're volumetrically expanding the situation, right? It's understood.
Right.
So the only way to keep the volume of this experiment at a limited number is to do dry. Now,
Yes.
you talk to people. These are typically the people that tell you can't do dry are the same guys that yell at you for going on your knees.
Yes. Yeah.
And they scream, what are you doing? You're on your knees. You're dead. You're dead.
You're
your whole
gonna
family's
die.
dead.
Right. The whole city's gone because you put your knee on the ground.
These are the same guys.
Ugh.
So, yeah.
But I bet you there are people right now that are getting a little bit upset.
Yeah.
Because,
Yeah.
we've been doing this since, I don't know, the beginning of time, since dogs have been in firehouses.
Yes.
And what is the standard practice that we teach?
Okay, so the standard practice is the slurry, right? The liquid to liquid, or the it's liquid to liquid. I would say that. That sounds about right. What we're saying is instead of making the slurry, take the powder that we typically walk around with and add it directly into that 320 to 1.
Oh my God, you just made my heart stop.
Right. So that's what we're talking about, right? So we're going to take the standard practice of using the neutralization with a slurry. We add it to the very weak neutralization product. And if we have a strong acid, we would neutralize it with a weak base.
Yes.
Dry acid, soda ash, whatever it might be.
So the reason for this is twofold, right? First, we know that we're using a weak neutralization product. The reaction is going to be limited. What do I mean by a weak neutralization product? If I have an acid, I'm going to use a base. That base is my neutralization product. If I have a strong base, I'm going to use a weak acid. That's my neutralization product. So it's really a weakened version of the opposite spectrum. Does that make sense?
Right. And now less energy means less chance of the reaction going out of control, right? Less chance that the reaction will boil over that thing. We've given ourselves a good amount of head start, right? It's 2.5 gallons of a 5-gallon bucket. We've given ourselves a good amount of rim to not go it over. It's just the right way to do it, Mike.
It always has been. It's always been taught that way, right? And the reason for the water in the slurry is the second safety factor, because the addition of that water is going to slow down the reaction by spreading the atoms apart.
This is why they use it as a heat sink. So not only is the 320 to 1 dilution that's there working towards this, but also the slurry itself. So it's released and absorbed almost immediately.
So then the question becomes, can we actually produce the same safety parameters that are built into the slurry method by using a dry acid or base neutralization? And we believe that the answer is yes.
Yes.
By doing what we talked about before, we have created a diluted solution with plenty of water to absorb the heat of the reaction.
Right. So we're going to add in some dry neutralization product.
How do we do that? Well, we do that in the same way that we added a strong acid or base to the water, in small and controlled amounts. We observe the observe the reaction, and we see what happens inside the solution. We're going to observe temperature changes. We're going to test the solution to see what kind of changes have been made to this bucket of diluted strong acid or base with the small amount of neutralization product that we have added at a very, very, very limited time span.
Now, so let me just tease this back because you might be confused because we talked about wet slurries, and now we're talking about dry slurries. We're starting from fresh again. We have a fresh, brand new bucket, fresh 2.5 gallons of water. We have that same nitric acid. I pour 1 ounce in there. It's 320 to 1, and action. Right, and now we're doing the dry slurry method. So I take this dry slurry and I put it in there, and if we adjust our tactics, if we all went well and we controlled the little bit we add, we repeat this process until our pH strip comes out as a 7.
Yeah.
And then we do it again.
Do it again. And again and again. And based upon our observations, we can adjust everything. And we can maintain that safety factor. We can use the acid. We can not have to make another slurry. We can keep the total product down to a minimum. But there is one small catch to this whole thing. This is tip number 5, is you need to go slow. The reaction is going to happen even when it is slow. There's going to be some bubbling up. There's going to be expansion of volume, especially if you have a really, really strong or your dilution is small. If you go too quickly and you're going to add your opposite acid or base, a couple of different things could happen.
Right. The solution can react very quickly, that it bubbles up and out of your container and makes a bigger mess.
And that's
So
best case scenario for bubble over, right? Because the worst case scenario is that stuff acts so violently that it shoots product out of the bucket of whatever solution you have, and now is reacting on you, and that is just not a good situation.
right, and just for the astute observer, we are in level B suits on air, fully turtled up on this one. This is not something you kind of do in shorts and flip flops.
Right.
Right, we're going to do this, and it's a big deal. So even though the neutralizations would go, let's say, smoothly and relatively quiet, we should always have an emergency decon set up, and that could be just a hose off a hydrant.
Yeah.
Locally.
Because, man, if something goes wrong, you need that. No joke. Right? The next reason to go slow and to take it easy is the heat of the reaction. If I go too quickly and I go to neutralize too much product, there might be so much heat given off in the reaction that you could literally melt your container. Yes, even with water in the container, you have the ability to melt it. You could soften that plastic to the point that it can't hold the weight of whatever is in there. So this is why we use small amounts of product in the beginning, and we use small amounts of neutralization products to start off with.
Right. And we can monitor the heat with a thermal imaging camera. If you don't have a thermal imaging camera, it's good. That has a good, precise room temperature. You can always just use one of those, laser temp guns that just gives you a number.
Yeah. And
they work really good.
They are phenomenal. You can't get a big picture. I love both of them. They really both have their own place. So you know what? Thermal imaging, totally different subject.
Yes.
Acids and base neutralizations, they tend to have a time delay. So it literally can be up to a couple of seconds before a reaction starts to take place.
Right. So if you sprinkle it in, and this is kind of like a side note, if you sprinkle it in, take a moment to take a stick and mix it up. Because it's going to fall right to the bottom, and it might not mix up. You want to make sure that whole reaction is completed. Then you pH it. Then you pull that pH strip out so not to get confused by the other pH strips that are floating in this mess.
The 400 pH strips by the time you're done.
Which one is it? I don't know, man.
I have no more water left because the pH strips have all absorbed the...
Yeah, it's a sponge. And I want to sprinkle a little more. Wait a second, stir it completely, and then do it again. You can see how this is going to take some time, but it's enough that you were able to... You can't have that impatient technician standing over the top of this container with a scoop of dry acid or base in their hand, waiting, and they're like, I don't see any reaction. Hit it again. No.
Yes.
Tell the guy, sprinkle, and make him physically put that scooper back in the bucket and wait.
And don't use the whole scooper. We're talking sprinkle the product in slowly. Right?
Yes.
We saw that happen. The guy was sprinkling. He got half the scoop in, and then he just bloom. And as soon as he went bloom, my little butthole puckered up, and I'm like, oh boy,
oh no.
Here. And sure enough, it bubbled up and it went right to the top. And I'm holding my breath because you got all the chiefs around and the other companies, and I'm like, oh, this is not going to be good. But it ended up not.
Settled.
So always. Wait at least 10 seconds is a really good amount of time to determine whether or not you should add more of your neutralization product.
Good.
Sweet.
All right.
Well, that wraps up another episode of the Hazmat Guys.
You can find us on Facebook, Twitter, and our YouTube channel at The Hazmat Guys, and take a moment to call our comment hotline at 843-628-1484.
And we are always looking forward to your feedback about information or interesting incidents that you were a part of, so send us a note at feedback@thehazmatguys.com.
Remember, guys, don't just get on the job, get into the job.